Good morning and welcome to Johnson Space Center and a special Facebook Live event. I'm Brandy Dean from the Public Affairs Office, and joining me today we have Kirk Shireman, the Program Manager of the Space Station Program.
Thank you. It's great to be here. I'm excited to be part of this event.
Well, we have an exciting event. We're going to be talking soon with astronauts Joe Acaba and Paolo Nespoli. And they are going to be helping us kick off the year of education on the space station. As you may know, Joe is a former teacher who taught in middle school and math and science in Florida for several years before coming to NASA. And then later this year, one of his astronaut classmates, Ricky Arnold, will also be going to the International Space Station. He also has quite a bit of extensive classroom experience. So in recognition of their special background as educators this school year, NASA and the crews aboard the space station are going to be using that special platform of the station to really push hard to inspire teachers and students here on the ground. Kirk, maybe you can tell us a little bit about why that seemed like a good idea for the space station program.
Sure. Well, we had a unique opportunity this year to expand the U.S. Crew members from 3 to 4. And then in the selection of the crew members to go fly those, we ended up with Joe Acaba and Ricky Arnold, and of course I would say it was not chosen that way, but since they both had an educational background, both educators, it just seemed like a great fit. What a great opportunity for us to go put a renewed and perhaps a much larger emphasis on education on board the International Space Station. So it really was a unique opportunity, and unique crew members said, hey, let's go do this. So I'm really excited about the opportunity this year, and I really hope that we'll take full advantage and have the chance to touch many kids and educators across the nation.
Absolutely. And I think the way we're going to be doing that, or a few of the ways we're going to be doing that, is giving some extra time to the crews to talk with students here on the ground, maybe even doubling what we normally do, and then also asking them to do some special demonstrations that we're calling STEMonstrations for STEM, the science, technology, education, engineering, and mathematics, giving them the chance to show what some of the science experiments that we might want to do here on the ground look like in space.
Sure. ISS is a fantastic laboratory. It's a laboratory like no other. And number one, and of course we have national labs across the United States that do very unique things, but this one in particular does things that are so out of the ordinary for all of us. It's just the kid in all of us, I think, comes out when you get to see what goes on the International Space Station. So we grab people's attention because it's in space, and then we can use that to really touch and inspire people to go work on their education. So I think we have a really unique opportunity with this national laboratory and with these educators this year. So we'll see how it goes.
I think that's got to be one of the best opportunities that we have to inspire students. I know I would have been amazed to have an opportunity like this when I was in school.
Absolutely. Of course, when I was in school, we didn't have people living and working in space. But today, we've had people living and working in space for 16 years, coming up on 17 years. And so there's people who are seniors in high school who've never known a time when humans weren't living and working in space. And we want to make sure that people know about that and are inspired by that. So this is, again, it's a great opportunity. And we have the ability, we have the people who have those skills on board, and we're going to take advantage of it.
And how long have you been with NASA, Kirk?
I've been with NASA since 1985, May 20th, 1985.
So you've seen a lot of changes over the years, and I'm sure the station's evolved a lot under your leadership as well. Anything that you think that would truly amaze students that you're hoping they'll get out of this?
The thing that's always amazing to me, anyway, is you think things work a certain way, and it turns out that they don't. And so and space is a great opportunity to see it. Certainly you can see very quickly that they work differently up there than they do here, but even the ones that you can imagine how they work, and it turns out that they don't work that way. That's the really cool thing. Right. So I hope that we'll see that. And then the next question is, well, why does it work differently than I expected? And that's where it really ties into education. What is the physics behind what's going on? And how does that physics, or that knowledge of the physics, then apply to problems, whether they're in space or on the ground, and allow us to build a better world for all of us?
All right. Well, we should be hearing from the Capcom calling up to the crew on board the station to start us off in just a second now. So we'll stand by for that.
Station. This is Houston. Houston, are you ready for the event?
Houston, this is station. We are ready for the event.
JSC PAO, this is Mission Control Houston. Please call station for a voice check.
This is Brandy Dean from Johnson Space Center Public Affairs Office. How do you hear me?
And this is the International Space Station. We have you loud and clear.
Great. It is fantastic to be talking to you. Thank you so much for joining this morning. And just so you know, I'm also here with Kirk Shireman. So we're both excited to be kicking off the Year of Education in Space with you guys. We have a lot of people on Facebook Live getting ready to send us in some questions, and we'll be taking those and sending them up to you. But first, I thought I'd give Kirk a chance to say hi.
Yeah, good afternoon. It's great to see you on board the ISS today. How are you guys doing?
How you doing, Kirk? We are doing great. It's really an honor and a privilege to be up here working on the space station. We're getting a lot of science done, and yeah, we're having a great time.
Excellent. Well, thank you for being part of this. You know, Joe and Paolo, part of the emphasis this year on education is really because we have the expanded USOS crew, and certainly because of your skills and your unique skills and that fantastic laboratory that you have up there. So we're really excited about the opportunity this year, and thank you for being part of that.
Yes, Kirk, as you know, because you manage it, this laboratory is an incredible place outside the Earth, for the Earth. And here we can do a lot of science, a lot of technology, but a lot of education. And it's very good that we start this year in space.
Okay, well, we will jump right into the questions. We've got one that's appropriate for the Year of Education kickoff. It's coming from pre-service teachers and faculty at the University of Houston downtown. And they want to know, as teachers and scientists, how can classroom teachers help their students get a better understanding of the nature of science and to do real science in the classroom?
Well, that's pretty cool. We're working with the pre-service teachers, especially having those that are close to home there in Houston. And, you know, I think one of the most important things that we can do as educators when we're in the classroom is to try to make things important to the students, but also tangible. And so I'm hoping that the work we can do together will be these pre-service teachers coming up with great ideas of things they might want to use to inspire their students, coming up with those ideas, sharing those with us, and then letting us help you back in the classroom. We have this here where we have some candies inside of a little plastic kind of a globe, and there's lots of amazing things that you can do with something as simple as this. So we're hoping that we can take advantage of the space station and your great ideas to help inspire those students.
All right, well, we've got some questions coming in from students as well. This one's from Jamil Kareem, and they want to know how frequently you observe auroras and are they detectable in sunlight?
Well, auroras are very interesting. This is my second long-duration mission, and in the previous mission, I was up here for about 6 months. I think I saw two auroras, just a little bit faint in the horizon. But this mission here is just incredible. We had some incredible auroras lighting up the whole sky at night. So from my point of view, they're a little bit unpredictable. In fact, they are a direct function of the activity of the sun and what happened between the interaction of the sun and the magnetic Earth, the magnetic field of the Earth. And we saw them. We saw many, many, many of them. And even today, a little bit fainter. If we go outside in the evening, almost every night we can see some of them.
And have y'all seen auroras from the ground? If so, which do you recommend? Which view?
So, you know, I'm a kid from SoCal, and so we don't get too many auroras down there. So it is, you know, one of my goals to go somewhere where I can see it. But one pretty neat story is we were going to Kazakhstan to pick up a crew member, and while we were flying, we could actually see the auroras. So that was pretty neat. So I haven't seen it while I'm on Earth. I've seen it in a plane, and I've seen it from here. So one of my goals. How about you?
Yeah, I would say that I saw one in Sweden. I had the occasion to be there, and it was very peaceful to me watching this aurora from the Earth. Up here in space, to me, it's a completely different feeling. We are spinning so fast, and the aurora is moving so fast. It changes completely, and it gives me a sense of something that is really active and a little bit less peaceful, to be honest. But spectacular, for sure.
I can only imagine.
One of the things I think is interesting in that is in the past I know some of your crewmates have taken videos of this and they put it to music, and that's one of the things I find fascinating. Is it's really as you pointed out, Paolo, it's a phenomena caused by the sun, which you have to see in the darkness, and yet people see art in that form as well. So it really kind of ties everything together.
Absolutely, Kirk. They are incredible. The colors, the shape, the forms, the way they go around the Earth, the way they spike up from Earth. It's absolutely incredible. We took time lapses, so we put a camera on a window, and then we let it take a picture every second, and we can combine in this way 1,000 pictures, and in a minute or in a couple of minutes show what the camera captures in about 15 minutes, and it's absolutely astonishing. It's beautiful.
And if I can just add one more thing from this conversation, is that for those teachers that are out there and those students that are out there, you know, we talk about art, and a lot of times we think art is separate from the sciences, and really they're not. So for those people that, you know, feel like they're more on the artistic side, you know, don't be afraid of the sciences, because it is an art, and so it's neat when you can bring those two things together.
I don't know that it would quite count as art, but it looks like y'all did an experiment recently that I think is going to capture a lot of school student attention. You sent down some video maybe over the weekend, but we've got a question about how does a fidget spinner work in space? So that may be inspired by the video you sent down.
So great question, and I'm glad we just we picked one up, and a video just went out on Friday, so you can see the space spinner that is out there. And what's really neat is, of course, is we're in this microgravity environment. You can get a really cool spin going, and you can release it. So you can see it'll pretty much stay there. And then if Paolo imparts any little bit of force on it, it will follow the vector of the force that he's put on that. So you can do all kinds of things. And this is just a good example of what the teachers can ask us to do to help explain some of the concepts that they're going to teach in the classroom. And the little spinner, it's fun, and we have a good time with it. And if you haven't seen the video yet, it's pretty fun.
Definitely. Well, kind of reversing it a little bit, we have a teacher, Joe, that wants to know what things you learned as a teacher that prepared you for being aboard the space station.
Well, I think being a school teacher it's an awesome job, but it prepares you very well, maybe more than any other profession, for being an astronaut. As all of you teachers know, you go and you start the day and you have a plan in place. You think you know what you're going to do every minute. Up here, we start the day and we have a plan in place, so it's very similar. But then as soon as those kids walk in the door and they do something or ask a question, there goes your plan. And so you have to be very flexible. You have to be able to think on your feet. And up here, it's the same way, where we think we have a plan, and if it doesn't go quite right, you have to learn how to fix it. You have to work as a team. And so, you know, being a teacher is, I think I can say it might be harder than this job, because we have all of Mission Control helping us, and you teachers are in your classroom by yourselves, and now you've got to fix the problem. So I think being a teacher really prepared me for this job.
Brandy, I am an engineer, and I just look at Joe and I admire his patience, because he has an enormous amount of patience with everything that happens and the capability of cope with almost anything. And that's, I think that comes from the dealing every day with the situation with students, with people, that of course each one of them pushes you in every direction, and if you're not flexible and patient, you're not going anywhere.
Joe and Paolo, it seems like one of the traits too is to see some phenomena not through your own eyes but through the eyes of a student, and then figure out how to explain it so that they understand it from their perspective. And again, I think that ties into your life every day, right? The rest of the world is down here on the planet. When you're doing an experiment, even with the principal investigator, you have to explain what it means from their perspective as opposed from your own, and that's a really unique skill.
Yeah, it's really interesting. You know, as a teacher, you know, I think I was a terrible math teacher for quite a few years because, you know, math came easy to me as a kid. I liked math, and, you know, it was pretty easy. So I taught the kids the way I learned and the way I thought was simple to learn, and it didn't work well for everybody. So you really do have to look at who you're talking to, and saying it 5 times over again doesn't make it any clearer. So we do have to find different ways to express what we're trying to say and how to get that concept across.
And that's one other thing about that too. It seems like, at least for me as a student, the applicability. In other words, so you're learning something. You're learning math, or you're learning. For me, it was algebra. You know, what's the point? What are we doing this for? And again, I think the space station and you guys up there can really help say, hey, this is why you're learning it. This is why it's important. It really does be able to describe the motion of things, or the biological phenomena. All these things apply, and here's why. So it's really the application of the knowledge that you're gathering.
Yeah, Kirk, that's exactly right. And that's why we want to get the teachers involved so they can tell us what they need, and we are happy to help them do that. And being astronauts, we are students. We spent years in training to get up here, and it's funny that you say that, where sometimes we're taught things and we want to step back and say, okay, now why do I need to know this? So even as adults, I think it's super important as we learn new things.
All right, well, giving the students a little bit of taste of what it's like in space, we have a few questions on kind of Spaceflight 101. And the Molanphy School wants to know what type of foods astronauts eat in space.
Well, I wish we would have a beautiful kitchen here where we can prepare all sorts of things. I crave from a pizza, actually. Yes. I like to have a pizza. Kirk, can we have a pizza up here, please? But the truth is that it's very, very difficult to cook and to handle fluids, especially hot fluids in this kind of environment. I would not say impossible, but very, very difficult. And therefore, the food that we have is something that can be managed a little bit like the food that we use in the military, those a meal ready to eat, food already prepared, or a TV, what is it called? A TV dinner, something like that. So we have thermostabilized food, we have rehydratable food, we have irradiated food, mostly meat, and what else?
Juices and coffee, but everything is contained in a bag. So it's either you have to cut the bag open to get to it. Sometimes you suck out of the bag, and it's a little bit different. We're looking forward to that pizza.
It's a picnic for 6 months, essentially. But at the end, we have enough variety here, so each one of us can pick his own preferred food, and it's actually pretty good, to tell you the truth. At the end, I thought it would be worse, but it's actually not bad.
And I would say tortillas are our friends up here. We don't have a lot of bread because of the crumbs that they create, but you'd be surprised at what you can put on a tortilla, so try that at home.
Like you've been playing with your food a little bit. If I think the ball of candy in the background is any indication?
Yeah, we're astronauts and we're professionals, but we're big kids as well, and we like to have fun.
Speaking of fun,
and we play with food sometimes, so.
Sorry about that. Speaking of fun, Hillary, or her 6th grade students want to know how gravity works differently in space. So maybe you can give us a demonstration.
Well, there is gravity here in space, but because we are falling down towards the Earth, and nothing is stopping us, so the spacecraft is falling, we are falling, I am falling, everybody's falling, the result is that essentially you don't feel the effect of gravity, and you can do a lot of things. It's actually incredible what happens when you go up here in space, because you come up here like a terrestrial person, so with gravity in your mind, and you start trying to walk. But how can you walk in these conditions? So you have to learn to walk with your hands. And then when you go somewhere and you want to stay stable, you cannot use your hands, because otherwise you cannot work. So you have to use your feet. And so it's kind of strange. You walk with your hands and stay still with your feet. And not only that, you tend to walk with your feet towards what we call the floor, but there is no floor. And you have to learn to move and to adapt and put yourself in a way that you can actually work effectively, efficiently. So you have to become Spider-Man, Superman. You have to become an extraterrestrial person. And it's actually fun. It's one of the discovery of space. It takes few weeks, I have to say, but once you manage this, it's absolutely incredible.
Yeah, Paolo, one of the things I find really interesting too, and just watching you guys here in this event, is you know, one of Newton's laws: when you put something in, a body in motion will tend to stay in motion. And you know, we know that from school, but you guys, even just holding that microphone and trying to leave the microphone sitting in one place, you know, any little tiny motion you leave on that microphone before you let go, it stays and just drifts off, and like the globe a minute ago drifted off into another module. So all these really fundamental laws of physics you guys live and breathe every day.
Yeah, and there are unintended consequences, because you learn very quickly that you just push yourself and you're going where you want to go. The fact that you forget that you have to stop. And so at the beginning you don't realize that, and when you hit the wall pretty fast and you start hurting yourself, you figure out that Newton laws, it's very important here, you better pay attention to it.
All right, we're getting close to the end of our time, but one other question that did come in that we wanted to ask is anything you can tell us about your favorite teachers and subjects when you were in school?
Well, I did like the sciences, so that was always fun, chemistry, physics, but my favorite class was actually my metal shop class in high school, and so we could take electives, and so I actually took 4 years of metal shop where we learned how to weld, work on a lathe, we were making molds, we were, just you name it, we got to do it, and to do that as a high school student, it was great. It prepared me for the different jobs that I've had. And as a teacher, I reflect back on that, and I wonder how Mr. Walters handled 30 high school kids with high-powered tools, with, welding, flames, and things like that. And, he gave us a lot of responsibility as students, and we loved that, and we ran with it. So it was great as a student, and as a teacher, it was really neat to look back and see how he managed the classroom.
And do you think you had any teachers that would have made good astronauts?
I think Mr. Walters would have been a great astronaut. When you look at what we do up here every day, a lot of it is doing repairs, and it takes someone who can work with their hands, who can understand a problem and find a way to fix it. But he might have been too good where he might have redone the whole space station, so it's probably better that we kept him on Earth.
Good advice. Well, last thing, anything you want to say or any advice you have for the students who'd be watching right now?
Well, if you're watching, we want to thank you for coming on board, and we hope that we can share our experience and show you how science is real, how science is fun. And I would just tell any student out there, find that subject, those subjects that you really love, and run with them, whether it's science or not. All of us that are up here, we have different backgrounds, but we all really enjoyed our careers before we got here. And when you find something that you love, it's It's more enjoyable to do. It doesn't actually seem like work. You get paid. And, you know, you may not always be the smartest person out there, like someone has told me many times, but you can always be the one that works the hardest. So don't be afraid to work hard and try new things.
I would tell kids that you know, math, science, research, these are not things for crazy people. Well, some of the people are crazy, but not people out of the world. We are not, you know, Nobel Prize winner or geniuses or anything. We are just regular people that have had the strength to have a dream and pursue it and eventually be up here. And if I made it, if Joe made it, it means it's possible. Everybody can do it. So just have a dream and wake up after you had a dream and just go at it, because you can actually do it.
All right. Well, thank you so much for sharing your dream with us. We look forward to seeing a lot more as we go through this great year of education on the station. Thank you so much.
Yeah, thank you guys. We appreciate it.
Thanks for joining us.
Station, this is Houston ACR. That concludes the event.
Station, we are now resuming operational audio communications.
It's without borders, and certainly what we're trying to do on the International Space Station is like that. While we were talking to these guys, they actually orbited about 1/3 of the planet. So anyway, it's just amazing to me that that they're seeing 1/3 of the planet in these few minutes that we were talking to them, and they can impact 1/3 of the planet or more.
Absolutely. Yeah, it's amazing, and amazing that they are able to take some time out for this, knowing what all else they've got going on.
Sure.
I know Joe's getting ready for spacewalk. So.
That's right. Friday we're going to go outside and do some more work outside. It'll be the third of our spacewalks, the last one really that we have planned until next year. Mm-hmm. So we're looking forward to Joe Acaba and Randy Bresnik going outside on Friday.
And I know you've also probably got a lot of work to get back to, but one more question for you.
Sure.
These guys get asked all the time, you know, how they became an astronaut, but how did you become a space station program manager? Was that something that you had any idea about when you were young?
Yes, absolutely not. Of course, when I was a kid, I was born in 1962. So people were flying in space by then. As a little kid, I got to see the first steps on the moon, which was really exciting. Although you know, it wasn't that said, hey, I need to go work for NASA. In my case, I was fascinated by airplanes. I loved airplanes as a small child. Even I can remember 5 years old building little balsa wood airplanes, and I wanted to build and fly airplanes. That's what I wanted to do. And so I went to school to be an engineer so I could build and fly airplanes. And I had the opportunity to go work on the space shuttle. And so, you know, what better airplane than one that flies in space and on the ground? And then from the space shuttle, I came to the space station. So just one thing led to another. But it's just been this, I would say, lifelong interest in flying and in machines that took humans faster and higher than they've ever gone before. It was my passion. It was my interest. And I'm like Joe and Paolo said. I guess it was really Paolo said, "Hey, just find something that you're passionate about and wake up every day and pursue that passion, and really anything is possible." Yeah,
as it's clear just watching you and watching these guys. Yeah. All right. Well, we are going to wrap up now, but of course, you're going to want to keep up as we go on with this year of education on station. A few ways that you can do that is by following us on Facebook. You can look for NASA JSC Education, and then on Twitter. Right now, with the crew we've got on board, several of them are on Twitter. You can look for them at Astro Acaba, and that's Joe Acaba's account, or Astro_Paolo for Paolo Nespoli. And Astro_Ricky, who will be coming up to join the space station crew next year. And again, with the spacewalk coming up, you're going to want to tune back into NASA TV for that. We'll be beginning that spacewalk probably around 8:05 a.m. Eastern Time on Friday. And you can watch that live on nasatv.gov/live. And As always, you can keep up with what's going on at the space station at nasa.gov/station. Thanks so much for joining us.
Thank you.